right, welcome back everybody. We're going to take a look at tree diagrams today. So we'll put that on page 22. And we'll call this tree diagrams. Page 22. Tree diagrams. All right, same thing like we did before. We're going to try to find probabilities of different situations. So I'm going to give you a little bit of information here. Let's just say the probability that somebody goes to jail is 0.75. So the probability they won't go to jail, well, it's got to add up to 1, so if this is 0.75, this has to be 0.25. And then let's say the probability that somebody is guilty is 0.8. Again, the probability that they're not guilty, it's got to add up to 1, so this has to be 0.2. So now let's take a look at some questions that we can ask around the situation. So I could ask you, number 1, what's the probability that you go to jail and you're guilty? 2, what's the probability that you go to jail and you're not guilty? What's the probability that you don't go to jail and you're guilty? And finally, what's the probability that you don't go to jail and you're not guilty? So we can organize this information 2 different ways, but the one way that we're going to focus on today or right now is through a tree diagram. So the first situation, there's 2 situations, going to jail and guilt. So that's the first situation I'm going to consider, jail. So the way we're going to make our tree diagram is we're just going to build it. There's 2 things that could happen. You could go to jail or you could not go to jail. So I'll just write down jail, no jail. What we do with the tree diagram is we put the probabilities on these branches. So for example, jail, the probability that someone goes to jail is 0.75. So I'm going to put 0.75 here. Now this could be either a decimal or a fraction that I'm going to put along this branch. No jail is 0.25. So I'm just going to put that here. My branches together have to add up to 1. So I know that I'm doing this correctly. The second situation that could happen is guilt. Or the second part of the topic is guilt. So I could go to jail, and 2 things could happen. I could be guilty, or I could be not guilty. So we could go over here looking at guilty, 0.8 for guilty, 0.2 for not guilty. Same thing happens here. I could not go to jail and be guilty of something, 0.8, or I could not go to jail and be not guilty, 0.2. So now let's go back up here. I've organized my information. Now let's go back up here to the question. The probability that I go to jail and I'm guilty. So the probability that I go to jail and I'm guilty is this pathway right here. So it's this pathway right there. So the way I figure out the total probability is I multiply these 2 values together because jail and guilt are going to be, let's say they're independent of each other. So we're going to multiply 0.75 times 0.8, and that comes out to be 0.60. You can always double check that. 0.75 times 0.8 is 0.6. All right, same thing. So this answer up here is 0.60. Now, jail and not guilty, I just go to jail and not guilty. That's just one pathway as well. Again, I'm going to multiply that pathway together. So it's going to be jail and not guilty, 0.75 times 0.2 is going to equal, let's get a calculator, 0.15. Go ahead and pause the video, and what I'd like you to do is get the other two before I do them for you. All right, let's take a look. No jail and guilty is going to be this pathway. 0.25 times 0.8 is 0.20. And then finally, no jail and not guilty, it's going to be this pathway down here. 0.25 times 0.2. So there's a couple ways I can multiply that together. 0.05, or I could have just added these together. So that's 60, 75, 85, 95. I know this had to be 0.05 because this all has to add up to 1. But to answer the original question, this one should be 0.05. Now, if I wanted to, I could have set this up. I'm going to just draw a quick little line right here. I could have set this up as an area model. Remember, I said you could do these two different ways. If, for example, I put jail here, jail would have been 0.75. So this is jail, this is no jail, and that would have been 0.25. Here's my area model. The other side would have been guilt. So I could have been guilty or not guilty. Guilty was 0.8 and not guilty was 0.2. And just like we did in the past, to get these areas, we would multiply them together. So 0.8, so guilty and jail would have been 0.75 times 0.8, which is 0.60. If you did all of them, those numbers should match those numbers up here. If they don't, then you probably made a mistake somewhere. All right, this box would have been the 0.25 times the 0.8, right? No jail and guilty. So that would have been 0.20. Not guilty and jail would have been this branch. And then finally, the last branch would have been no jail and no guilt, 0.05. So you can see we get the same numbers. It's just another style of doing the mathematics. The advantage of a tree diagram is we're limited to 2 situations at a table. In a tree diagram, I could have 3 situations. I could say, I could bring in jail, guilty, and ethnicity or something like that. All right, so we could bring in more than one thing. All right, what I'd like you to do is go ahead and flip the page, and I'd like you to try a problem using a tree diagram. All right, so here is your situation. So let's say, slide this down here. Let's say I have 2 bags. So bag number 1 and bag number 2. And inside each of these bags, I have some marbles. Red, 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 green, 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 green. So 4 reds, 6 greens. And on this bag, I have 2 reds and a green. So what I'd like you to figure out is, number 1, what's the probability of choosing a red and a red? What's the probability of choosing a red and a red from the first bag and a green from the second bag? All right. Go ahead and pause the video, set up a tree diagram, and see if we can answer these questions. All right, let's take a look at your tree diagram. So bag number 1 is my first situation. So I can either pull out a red marble or a green marble. The probability that I pull out a red marble is 1, 2, 3, 4 out of a total of 10. So this is going to be 4 out of 10. The probability I choose a green marble, 1, 2, 3, 4, 5, 6 out of 10. All right, now I have to go on to bag number 2. Again, in bag number 2, I could choose a red or a green. Again, a red or a green. Bag number 2 has 2 reds and 1 green, so a total of 3. 1 green and a total of 3. Same thing's going to go on this side. All right, now I've got to look for my situation. So I'm looking for a red and a red. So here's a red, and all I do is multiply them together. 4/10 times 3/10, or 4/10 times 2/3. So I'm going to multiply straight across. So that's going to be 8 over 30. Go ahead and leave them as fractions, all right? All right, next one, red and green. So let's be careful with this one. Here's a red and a green. And here's a green and a red. So there are 2 ways I could get a red and a green. Now, if you thought about it as I've got to get it in some specific order, then I'm only talking about this situation, 4/10 times 1/3. However, if you thought about it just in my hand, I have a red and a green marble in my hand, then there are 2 ways that could happen. The first way here and the second way down here. So the probability of this first way is going to be 4 out of 30. The probability of the second way is going to be 12 out of 30. If you thought of it as 2 different ways, then what you have to do is add these 2 together. So you get a total of 16 out of 30. If you put 4 out of 30, that's fine. Just understand that you're talking about one specific way. If you're talking about whether red and green and red could be mixed, then you need to consider adding those together. All right, and there's your example of a tree diagram. Thanks for watching.